Okay, so we're doing integration by substitution. So these are some basic examples. So let's look at our first integral. So again, when you do integration by substitution, you're looking for your integrand in a form that looks like this, where you have a function inside of a function, and then the inside function's derivative is somewhere in that function. Okay, so this is the basic form. So when I look at my integral right here, that's what I see. I have a function inside of a function, and then the derivative of x to the fifth is x to the fourth. Okay, so I do have this kind of form sitting here. So I'm going to say my u is negative 3x to the fifth minus 1. Take the derivative, and you get negative 3 times 5, which is negative 15x to the fourth. Derivative of negative 1 is 0 dx. Okay, so this right here is what you're going to substitute for du. And then this right here, this is u. So when you're done substituting, you're going to end up with the integral of u to the fifth du. And so this is the whole point of substitution. It's getting your integral into a form that is very, very simple to integrate. So now you just take the antiderivative. So you take u, add 1 to the power, divide by the new power, plus c, your constant of integration. And then the last thing you got to do is plug in u back in. So your antiderivative is going to be negative 3x to the fifth minus 1 to the sixth power over 6 plus c. And that's your antiderivative. Now remember, you could also, whatever you finish with, if you take the derivative of that, you should end up back where you started. So if we take the derivative of our answer, we should get this back when we take the derivative. Okay, so that's a way of checking your work. Okay, so that's one of the basic examples. So again, we have this. Okay, the first thing I see a function inside of a function. So I'm going to pick this to be u. So u equals e to the 4x minus 4. Then I take the derivative. And then to do e to the 4x, you got to do chain rule, because you have a function inside of a function. So the derivative of 4x is 4 e to the 4x dx. Now, I don't have 4 e to the 4x, I have 8 e to the 4x. So I could either split this into 2 times 4 and move the 2 out front, or to get this to match, I could say, well, then 2 du, multiply both sides by 2, and I get this to match. Either way, once we substitute in, we're going to have this 2 out in front, and then this is my u, so I get u to the 1/5 power du. Okay? And then you take your antiderivative, so add 1 to the power, so 1/5 plus 1, that's 6/5, and there's this 2 out front, divided by 6/5 plus c. And dividing by 6/5 is the same thing as multiplying by 5/6, so that's going to be 5 over 6 times 2, which end up being 5/3. Plug your u back in, which is e to the 4x minus 4 to the 6/5 power plus c. And that's your antiderivative. Okay, so basically it's the same as the last one. Alright, this one here. Now this, you'll see, is kind of a special case. So just like in the notes, I'm going to pick this to be u. Okay, so u equals 2x plus 3. And du equals 2 dx. And then that means that 1/2 du equals dx. Okay? Because I don't have 2 dx, I just have dx, and here I have 5. The 5 we're just going to move out anyway, so it's not going to make a difference. Okay? But I still have this x sitting there. And this is where sometimes I have to use my original u to actually substitute in for x. So what I'm going to do here is I'm going to solve this for x. So you're going to get x equals, and this is going to be 1/2 u minus 3. Because you're going to subtract 3 from both sides, so minus 3, and then divide both sides by 2, and that's what you're going to get for x. So I'm going to plug in this for that x. I'm going to plug in this in for u. Okay? And for dx, I'm going to plug in this. Okay? So when I finish plugging in all of my stuff, I'm going to have that 5 out in the front. For my x, I'm going to have 1/2 u minus 3 times the square root of u times 1/2 du. Okay? And like I said, we moved this 5 out front, so this right here, that's x. This is what we ended up with, the square root of 2x plus 3. And then this is my dx, and here's the 5. So I still have accounting for all of my stuff. It's just now in terms of u. So now I'm going to simplify. So this 1/2 and this 1/2 are constant, so I move that out. So I get 5 over 4. I'm going to distribute this in here by using u to the 1/2. So when you have two things with the same base, you add their powers. So this ends up being 3/2 minus 3u to the 1/2 du. Okay? So all I did was I moved part of it out. So I moved this, and this outside, and then I multiplied that in. Now it makes my antiderivative easy. So I get 5 over 4, and then the antiderivative here is going to be u adding 1. I'm going to get 5/2 divided by 5/2 minus 3. U add 1, you get 3/2 over 3/2 plus c. And then you just simplify. So this ends up being 1/2 u to the 5/2 minus 2/3 times 3, which will end up being 2u to the 3/2 plus c. And then the last step is plugging back in u. So it's 1/2. This is 2x plus 3 to the 5/2 power minus 2x plus 3 to the 3/2 power plus c. So this one had a lot of algebra in it. Okay? A lot of algebra. But the antiderivative part, again, we just had this one extra step where I had to solve for x to get it all in terms of u. Okay? And then my last one, so again, start off by looking at it. So I'm going to pick this right here to be u. So u equals 5 plus the natural log of x. So du equals 5 is 0, the natural log of x, the derivative is 1 over x dx. Okay? So it almost looks like I don't have what I need, but we can rewrite my integral like this: 5 plus the natural log of x to the fifth times 1 over x dx. Because dividing by x is the same thing as multiplying by its reciprocal. Or you could actually think about it as if I were splitting fractions by using multiplication, because when you multiply fractions you go straight across, so this would end up bringing you back there if you multiply the two. Either way you want to think about it, but that means that all of a sudden makes my life super easy, because basically this is going to be u to the fifth, and all of this right here, that is my du. So this is u to the 6 over 6 plus c. Plug in your u, and you get 5 plus the natural log of x to the 6th over 6 plus c. And that is our answer. Okay, so actually this one, the fourth one, looked more difficult than the one above it, but it ends up being easier because of U-substitution. Okay, so just make sure that when you're done you have everything back in terms of x, and when you're substituting in u, everything has to be in terms of u. And sometimes we have to do a little extra work to get that last x to work.